All right, so now that we know how to identify some things that are binomial, let's take a look at what we can do once we figure out whether or not something is binomial. So according to an airline, the afternoon flight from Peoria to Dallas is on time 79% of the time. Suppose 5 of these afternoon flights are chosen at random and the number of on-time flights is recorded. Okay, so we're going to pick 5 at random. We're going to look at of those 5, how many were on time and write it down. And we're going to do that over and over. Okay, so determine whether or not this is a binomial experiment. So can we determine or decide what would be a success and a failure? Yes, we're on time or we're not on time. Okay, do we have repeated independent trials? Well, yes, these are repeated and they are independent because these are 5 flights that have already happened in the past. And what happens on one flight on one day has nothing to do with what happens in another flight on another day. Okay, so yes, this is a binomial experiment. And do ask yourself, go through those steps, okay? I know this is a section about binomial, but in the next chapter, it's not going to be about binomial anymore. And when all these scenarios get mixed up on the same page, that's when people start to get confused. So start walking yourself through the steps now, okay? Start good habits now. Create a probability distribution. So what we're going to do in this case is we are going to make that table, okay, with X being your on-time flights. So out of 5 flights, we could have anywhere from 0 to 5 of the flights be on time. So those are our X values, how many flights are on time. And then P of X is the probability that they're on time. And you might be thinking, well, how the heck am I supposed to figure this out? All it says is they're on time 79% of the time. Well, yes, but this is where your calculator comes into play, okay? So, new stuff. This is not just one variable statistics. You get to do something new. Woohoo! All right, so what you want to do first is you want to press your second key. And then you want to go find the key that says VARS, V-A-R-S. Okay, and that should be right next, just to the left of your clear button. Above it, it says D-I-S-T-R for distributions. That's really what we're accessing is the distribution menu. Okay, then you're going to arrow down and you're going to go quite a ways. Okay, you should be going, I think in most of your calculators, to letter A, which should say binom PDF parenthesis. That stands for binomial probability distribution function, which is what we're trying to make, a probability distribution, okay? When you press enter, after you get there, okay, it's going to take you, for most of you, again, to a screen that has some prompts on it. Now, when it says trials, okay, trials is going to be your total number, or in this case, N, okay? So here it would be 5. Then it's going to say P. Remember, that's your probability of success. So I'm going to use a different color here. N here is 5. P here is 0.79, the probability you have an on-time flight. And then it says X value. Okay, X value is going to be changing. Okay, it changes. Again, here it's going to change from 0 to 5 because those are the X values that we're looking for. No flight is on time, 1 flight, 2 flights, 3 flights, etc. Now, those of you that don't have the screen that says trials, P, and X value, you need to type those 3 numbers in parentheses separated with a comma. So if you don't have those prompts that say trials, P value, X value, on your calculator, it will look like this, binom PDF parenthesis, and then you're going to type 5, that's your N, then you're going to type 0.79, your P, and then you're going to start with a 0, okay? And then you're going to hit enter. It will pop up a probability for you, and this is one, again, that's going to be in scientific notation. We're going to round to 4 decimal places, so you should get 0.0004. is the probability that none of those 5 flights that you happen to pick out was on time. Now you're going to do the same thing, but we want to do one flight now. So the 5 stays the same, the 0.79 stays the same. All we want to do is change the 0 to one flight. Before you go through that whole process again, let me give you a shortcut. Press the second key and then press enter. That is your copy and paste function. Okay, what that does is it should copy and paste the last thing that showed up on your screen. You can arrow back over a couple of spaces and change that 0 to a 1 and hit enter again. And it will give you the probability that one flight was on time, 0077. Repeat that. Second, enter, change the 1 to a 2, and then get that probability. Okay, so I'm going to pause real quick, and through the magic of iPad, the other values are going to pop up here real quick. Ta-da! Look how fast that went. All right, hopefully you got the same values. Again, if you're having calculator issues, ask. Okay, you're not going to be able to do any of these if we can't get the calculator working correctly. All right, find the mean number of flights that would be on time. Okay, mean number of flights is mu. We are looking for mu. So remember, all those x values, now they go into L1. Your probabilities go into L2. And we go back to our good old friend one variable stats. Mu is the same as x bar. You should get 3.95, and our unit here are flights. Okay, 3.95 flights. What the heck does that mean? Okay, interpret the mean. So that means on average, we expect about 4 of every 5 flights to be on time. At least those flights in the afternoon from Peoria to Dallas. Okay. Find the probability that fewer than 4 flights are on time. Well, now we're back to actually a question like we were doing in the last section. Okay. Fewer than 4, probability that x is less than 4. X is less than 4. So you can do one of two things. Okay, you have two choices. One's a little faster than the other, but not by much. You can either add up the probability that no flights are on time, 1 flight, 2 flights, up to 3 flights are on time, or if you prefer, you can do 1 minus 4 flights are on time minus all 5 flights are on time. Because remember, the values in this table right here, these have to add up to 1. Okay, so you can either add up the 4 values that you want, 0 through 3, or you can subtract out the 2 values you don't want. Again, take your pick. It's just a matter of preference. Either way you go, you will end up with 0.2833. Okay, and then last but not least, find the probability that between 2 and 4 flights inclusive, so that means including 2 and including 4 flights, are on time. So this is the probability that 2 is less than or equal to x is less than or equal to 4. And here I'm just going to go ahead and add up the probability that 2, 3, and 4 flights happen to be on time. So again, we're going to take these values right here that I'm circling in pink. We're going to add those up, and we're going to come up with our total probability of 0.6842.